Hi guys, we are on page 61. We're going to start to look at growth and decay. So the general formula starting here, we have a growth formula and a depreciation formula. You'll notice they're identical except for there's a plus and a minus. So if I have growth, I'm going to be adding the rate. If I am depreciating or decaying, I'm going to lose the rate minus there. So you see the A is the end amount, P is your starting amount, R is the percent. We want to make sure we change that to a decimal, and then T is time. So looking at the first one, a biologist is modeling the population of bats on a tropical island. He first starts observing them in the year 2005, and there are 104 bats. So that is our initial value. Okay, that is our P. Now, he believes the population is growing at a rate, so we will be using the plus, and at 3%. So a formula for that will be B of T. If they give you some function letter they want, make sure to use it. We'll start with 104. 1 plus the 3% becomes 0.03. Moving it over 2 places to the T. So there is our formula. B says, using that equation, how many bats are there in 2015? So 2015 is 10 years away. So we will say B of 10 equals 104, 1.03 to the 10th. So getting a new document, we're going to say 104 times 1.03 raised to the 10th. And I have 139.7. Now, you can't have half a bat, so you will say that there are 139 bats. Okay, next part is saying, using your equation algebraically. Now, when you see that in there, you want to definitely try to do it algebraically. You can always look at it graphically to know the answer, but we are going to continue to practice the algebraic method so you can get full credit. Determine the number of years it will take for the bat to reach a population of 200. So that is your end amount. So you'll say 200 equals 104 times 1.03 to the T. We're looking for time. So we need to solve this. I see that I have the variable in the sky. I am going to first move things away from that base. So I'm going to divide by 104. Now my suggestion is leave it right in fraction form because it's going to come out as an ugly decimal and you don't want to have to worry about not using the whole decimal and changing your answer. Okay, so now I'm in exponential. I want to turn it into a log. So log base 1.03 of 200 over 104. So using all the stuff that we'd learned recently, I'll type that in and I get T equals 22.12. And now here's where these questions you really have to be careful. We've done the algebra. We have correctly solved for T. Determine the number of years it will take for the bat to reach 200. Now, technically, if you look at 22.12, that rounds down to 22. But at 22 years, if you plug that in, they have not reached 200 bats. It's during the 22nd year. So you're going to write during the 22nd year or after the 23rd year. So that answers both questions. All right, now we are going to have a stock that is declining. Okay, so there's the first thing. I'm going to be using the formula that has the subtraction in it. Steady pace of 5%. Now notice per week. In the last one, it was talking in terms of years. So you want to be careful of how long they're telling you that they are checking in. The original price is $22.50. So we're going to be looking $22.50, 1 minus 0.05 and they said 6 weeks. So that one is done. Then we will type that right in, and you will find out after 6 weeks it is 1653. Now money's easy, 2 decimal places. Algebraically determine the number of weeks to reach $10. That's an end result. So that goes over for A. And you can again write the 1 minus 0.05 or write 0.95, what it's equivalent to. And I'm looking for this. So first step is to get this exponential by itself. So I divide by 2250. And I will have, and as I said, just leave it like that. Variables in the sky, so at this point I say, okay, I have to take logs. So log base 0.95 of 10 over 22.5 equals t. You're going to plug that in. You get t equals 15.8. So in 15 years, you would say, in 15 weeks, they won't be exactly at 10. So then, round your answer to the nearest week, it's going to take 16 weeks to get down to $10. All right. Let's look at another one. A car is valued at $25,000, depreciating at a rate of 15% per year. What will it be worth after 5 years? Round to the nearest cent. So formula, P times 1 minus R to the T. So 25,000, 1 minus, this becomes 0.15, and the time is 5. That one's nice, plugs right in, rounds to 63 cents. Okay, and how many years will it be half of the original price? So half of 25,000 is $12,500. So that is our end. 25,000 goes on this side. And again, you can write the 1 minus 0.15 or 0.85. Divide first. You get 1/2 equals 0.85 to the T. Use logs. Log base 0.85 of 1/2 is T. So we get T equals 4.26. How many years will it take? So we're going to say during the 4th year after 5. All right, let's skip the deer one for right now. We'll go down here to the new cost. It says we have a brand new house, $120,000. It appreciates to $135,000 after 10 years. What is the rate of appreciation? So this is a different setup than we have. The new price, $135,000. Original price, $120,000. We know it's appreciating, so it's 1 plus. Normally they give us the rate. That's what we're solving for this time. And that's going to go to the 10th power because they're saying this happened in 10 years. So the steps, just a little bit different. Still divide over to get the exponential by itself. And I'll have 1.125 when I divide those. 1 plus R to the 10th. So to get rid of the 10th power, I'm going to take the 10th root or raise it to the 1/10. When I do that, this side will become 1 plus r. This side becomes 1.0118. Make sure you are using the caret. Make sure you are using exponents, not multiplying. So then subtract the 1, and you have 0.0118 equals r. So that's the decimal form. Move it over to 1, 2, and you will have 1.18. They asked for the nearest tenth, so the rate is 1.2%. Okay, next, brand new truck. So exact same setup here. The truck depreciates. Cars always depreciate. Houses go up. Now it's 1 minus r to the 6th. So in this one, first you would divide, then I want you to raise it to the 1/6. So your first step, that's going to reduce to 37 over 45. I think it's easier to leave them as fractions. So, as I said, raise that to the 1/6 power. Raise this side to the 1/6 power. I want you to finish it up. I'm going to let you know you should end up with 3.2%. Okay. Our next one are half-lives. Half-life formula. So instead of it growing, we're going down, okay? So when I look at this, take a minute to read through number 1. Actually, before you read through number 1, same things here. Ending value, starting value, time, and the half-life. So it's P times 1/2 to the time over half-life. So we're going to be using radioactive isotopes. We go through the half-life right there. They tell you 8.02. We're going to start with 20 milligrams. All right, they want to know the amount of time to the nearest day it takes, so it gets down to 7 milligrams. So my end is 7. My beginning is 20. The 1/2 is constant. They're asking how long does this take? And then we know the half-life is 8.02. Now that it's set up, we'll continue through. Solve just like normal. Divide by 20. And again, leave it as a fraction. You have an exponential, variable is in the sky, cannot solve that. You want to go to logs. Log base 1/2 of 7 over 20 equals t over 8.02. So I will plug this part into the calculator, and I get 1.514, going on, using the whole decimal in the calculator. Put that over 1, cross multiply, so t equals 12.146. Now, again, determine to the nearest day. So that gave you very specific rounding rules, that rounds to the nearest day of 12. And if you're looking at it, 12.14, that would round down. Is it exactly 7 when you're at 12 days? No. So if they say, how long does it take to be exactly that, you'd have to go up to the 13th day, or say during the 12th. Now, I want to just point out one fun fact about the next one. It says it has a half-life of 6,000 years. It says that it has 1/5 the original amount of the sample remains. And they want to know how long that took. So I want to just show you some amount started, some amount ended. And then the formula is 1/2 t divided by 6,000 for the half-life. Whatever happened here when I divide, that gives me 1/5. So now we're right there. What I'd like you to do is finish that one. You're going to end up with an answer of 14,000, okay? Try that one. And then lastly, word problems dealing with a little more excitement, dealing with the E. So we have the hot liquid cooling, all right, and it gives us the function. So this one was nice. It set it up for us and is now just going to ask us a question about it. So you start with this one. What's the initial temperature? Initial time is 0. So you're going to do T of 0 equals 101 e to the negative 0.03. Plug in that 0 plus 67. Now we know anything to the 0 power, that e is raised to the 0 power is 1. So 101 plus 67 is 168. Okay, next, interpret this. This is now you're saying, do you understand what this means? So the number inside here is the x value, or your t in this case. So it's saying 60. So that's time in let's see, what are we in? Minutes? Minutes, there we go. So after 60 minutes, the temperature, and that's what the T of whatever is, the temperature is 83.7 degrees Fahrenheit. Okay, next one, when is it going to reach 100? Now this is very specific instructions, nearest tenth of a minute. So plug the 100 in here. Step 1, move things away, subtract 67. Next, divide. And again, leave it as a fraction. It's easier for everybody. Now I'm going to be doing logs, but base is e. So base of e is really natural log when I do that, I get negative 1.186, continuing on. Divide out by the negative 0.03 and you will get 37.287. They're saying nearest tenth, so 37.3. Okay, process that.